All right, hello. So I've been studying plastic pollution before I came to Northeastern and throughout my time here for the last 9 years. And I couldn't decide whether to call it tracing global consumption or global waste, and so you'll kind of see where I get to here. But I wanted to start on a beach in Bermuda called Whalebone Bay. Out of the many, if you've been to Bermuda, you know that there's no plastic production company, there's no plastic processing facilities, but yet this little 10-centimeter area on a beach that I just happened to go swimming at in Bermuda, you can see that there's all of these little pink dots represent these industrial resin pellets or plastic pellets. So they're all about 3-4 millimeters. They look like little hamburgers. I'm passing around a little vial of them that I collected there. And these are traces, right? How did they get there? The easiest way to do that is to study that at sea, and how we collect these, how we tell stories of these traces of plastic in the ocean, kind of where they come from, kind of trying to figure out the stories that they're telling. You can see where Bermuda is. I'm going to also passively aggressively in these 10 minutes try to dispel some myths about how we sometimes, mass media, general public, interpret some of these traces. And so I just want to play this quick video by a collaborator of mine. And so what this video, if I can get it okay, is showing is if we were to ubiquitously spread plastic pollution around the Earth one time and not reintroduce it, where does plastic go after 1 year, 5 years, 10 years? And this is just a 10-year loop. And you can see in the beginning that it quickly spreads away from the equator because of centrifugal force and currents, and away from the coastlines. And it forms into these 5 gyres. And sometimes they're called vortexes or giant plastic patches. And so this is the best place to study what kind of plastic exists, where it is, if it's increasing over time, and possibly what kind of plastic it is, so we can determine how long it might last there and where it's coming from. So how we do that on these sexy sailboats, in my experience. And this is what it looks like, how we actually collect plastic at sea. So we're on this giant sailboat. It's also a robust oceanographic vessel. A boom with a net that it has 1/3 of a millimeter mesh. We throw it overside. We tie it to it for 1 nautical mile, which is 1,852 meters. And we count how many little pieces of plastic, or students, excited undergraduate students, count all these little pieces of plastic that are all smaller than the size of your fingernail. The average weight is 0.018 grams. So it's not these giant landfills you think about. It's tiny little pieces of plastic. We haul the pieces back. We divide it by the area that we covered, and we can start to extrapolate, okay, there's this many pieces per how many square kilometers. So the pieces, like I said, are all very small. Sometimes we collect fish and dissect them, and you can see I squeezed out the stomach of one little poor triggerfish and counted 47 pieces of plastic in its stomach there. And so when we first all started hearing about the Great Garbage Patch, it was done, that all came from 11 tiny little net tows that a yachtsman did in the middle of the Pacific, and started saying, it's just twice the size of Texas, and this is a huge problem. And based on that, what I heard about from that coming out in 2006, I was like, well, I've been working on these sailing vessels for years. We have tons of data. And I started putting the 22 years of the Atlantic data together into what you see here. This is published Science, 2010. And you can see that all these little black stars in the center here are all areas where there's more than 200,000 pieces per square kilometer. So what you saw in that little dish earlier, those tiny little pieces, that was about 50 pieces per square kilometer. So that was just what we collected in this tiny little swath. So you can see that these traces, these little pieces of plastic that we think about, oh, well, it doesn't seem like that much. If you scale it to the size of the ocean, you can start kind of putting a story together. And if you have 22 years of data on these annually repeated cruise tracks, you can really start to tell a story. So we estimated in this area of higher concentration, in kind of the reds and yellows, about 1,100 tons, metric tons of plastic in the ocean. And then went on in 2014 to publish data about the Pacific. At that point, we had been there for 10 years. This box shows the area of high concentration. The estimate of that area is about 21,000 metric tons of plastic in the ocean just at the surface. There's really not that much. Surface tension is amazing. It more or less stays at the surface. And so now we start asking all kinds of questions. Where does this plastic go? What kind of plastic is it? Is it increasing over time? We can start asking many questions. And so we worked with that same model you saw earlier, the animation of saying in that box of where we saw tons of plastic in the Atlantic, where is that plastic coming from? So what you see is that box highlighted and bounded in a red box. And everything that ended up there, where did it start from? So you can start to see little literal traces done with analysis of surface currents, wind, currents within the top meter of the ocean with friction. Where does this plastic come from? And the estimates are plastic really takes less than 60 days to get far from the east coast of the US. Miami, from Miami it takes 45 days, New York 30 days, Boston 35 days to get to this box. And so it really happens pretty quickly, and then what happens then? And then if we say what happens when those pieces leave that box based on ocean currents and wind, it really is pretty confined due to currents, due to wind. These 5 gyres are areas of converging currents, hardly any wind. It's at the same latitude, 30 degrees north and south as the world deserts, and so you can kind of picture what that's like. It's very hot to sail through, trust me. And really the fate of it is it can break down to smaller and smaller pieces, and we don't catch much of it anymore. Getting back to those resin pellets that are going around. So that's the one success story we have seen. So in these areas, we have not seen an increase or a decrease in the amount of plastic there in either ocean. So it's incredibly variable. With the proxy of how much plastic we are discarding in the United States, this is 1960 to 2010, all the EPA municipal solid waste studies, our plastic discards have almost exponentially increased over time, and as a proxy for how much might end up through gutters, beaches, wind up in the ocean, you would imagine that we would see an increase in these areas, but we have not. The one success story is the pellets. We did see a not exponential, but a 90% robust statistical decrease since 1986 to 2010 in the amount of resin pellets, and that's because in 1991, the EPA released a study that said there's tons of pellets in the ocean, what are you guys doing in the coastal areas? And the plastics industry voluntarily started putting in sieves, kind of cleaning up, put a prevention program into releasing pellets. And so we saw, no one knew if that actually worked in the ocean, and in our data set, we were able to tell that story, so that was exciting. This is trying to put all those separate science papers together into one map. The North Atlantic and Pacific is all the many trips that I've been on, 20 of those and all the data there. And then the South Atlantic, you can see there's minimal studies. It's amazingly huge, and people don't quite understand the blue marble that you were talking about earlier, but how vast, and ideas of cleanup are kind of a disaster. Anyway, the point is, it's really challenging to kind of look at all of these tiny little traces and what we've seen in these different areas. Then how do you visualize that? I can visualize the area where we saw 23,000 pieces of plastic that we collected in a single tow, that big one in the Atlantic, but it gives the impression that there's a giant Atlantic plastic patch in the middle of the ocean. So what kind of plastic is this? Well, in the United States, we typically discard and recycle 3 times more of these buoyant plastics than other types of plastic, and that is in fact what we find in the ocean, buoyant plastics. So it's kind of a problem that we are in fact producing more waste in that regard. In the buoyant resins, the plastics, which are number 2, 4, and 5, if you look at the bottom of your yogurt cup or whatever, and then water bottles and such are in the bottom. So if you want to know more about this, it's all in this 45-minute documentary, Into the Gyre. Just shameless plug. I was part of this. It was a very cool project. It's on Vimeo on demand, and I'm happy to answer questions at lunch. Thank you for inviting me.